Euclid's proposition 22, this is book 1, proposition 22, he starts out with a line, okay? And give me just a second here. This line starts at point D. It passes through point E, but I'm going to go a little bit closer on this. You see this symbol right here? This is the infinity symbol. And that means that this line starts at point D, goes through point E, but it keeps right on going all the way to infinity. And you can kind of remember this. Let's say you remember the Toy Story famous line, to infinity and beyond. Alright. Anyway, enough about infinity. Let's just start this way. First of all, you got lines starting at point D, passing through point E, and going on forever. And then you have 3 other lines. You have line A, line B, and line C. And what Euclid wants you to do is he wants you to draw 3 equal lines across here that will form this triangle FKG, and you'd have FK equaling to A, and of course FG equaling to B, and KG equaling to C. Okay? So the length of FK is equal to A, the length of FG is equal to length of B, and the length of GK is equal to length of C. How do you do this? Well, Euclid says, I want you to hover line A over line D. And using proposition 1-3, you're going to cut off DF, and it's going to be equal to line A. Alright? And then he says, I want you to hover line B across here. And he says, I want you to make the length of FG equal to B using proposition 1-3. And you're going to do this one more time. You're going to hover line C over this line over here. You're going to make GH equal to C. And then the construction begins. You're going to take centermost part F, outermost part D. You're going to make a nice little circle, and you're going to make a circle that's DKL. And then you're going to make one more circle. You're going to have centermost part G here, outermost part H. You're going to make another little circle, and you're going to have KHL. Alright, so then you're going to draw a line from K to F and K to G. Alright, here we go. Now, we already know that the length of FD and FK are equal because all radii of a circle are equal. And so, since F was the centermost part and D was the outermost, FD is equal to FK because all radii of a circle are equal. Similarly, we have the length of GH right here, GH. We've made our circle, and the length of GK is equal in length to the length of GH because all radii of a circle are equal. Therefore, since we already know that the length of GH is equal to C, we know that the length of DF is equal to A, and because of that, and because all radii of a circle are equal, FK equals FD, and FD equals A, so therefore FK equals A. Alright. And we already said, because of proposition 1-3, that the length of FG is equal to B. And so therefore, we have formed a triangle in which all 3 of these lengths here can be found right up here. And that's our proof. I will tell you more in a future video, so stay tuned.